Hello guys. So in last class we studied special integral in which we consider the three formulae 1 over x square minus a square, 1 over a square minus x square, 1 over x square plus a square, and we discussed the two types. One is standard form and other is modified form, which can be converted into standard form easily by using the method substitution. So we use these two parts, two types. Right now in this class we will take one or two question of previous class and we add the type 3, that is 1 over quadratic form, which can be solved easily by making it as perfect squares. So we will use the perfect square method, and on using that we convert that quadratic equation into sum or differences of two squares. One is variable square and other is constant square, and then we will use the given three formulae under special integration. So right now we are taking one more question from type 1 and one more question from type 2. So type 1 means the standard form. Like a standard form means we have directly in format of standard formula, and we will do little bit manipulation, like we will take common a number from the given question and we get the standard form, the formula format, just like we are taking integration of dx over 50 plus 2x square. So we will take a step first in which the coefficient of x square should be 1. This is essential first step. The multiple of x square should be 1. So on taking 2 as common or extracting 2 from this expression, we get result x square plus 25. Right now it is very easy. This is the summation of x square and this is the square of 5. So right now this is the standard formula of 1 over x square plus a square dx, and the result is 1 over a tan inverse x over a. So x is right now x and a is 5. Now on using this formula we get 1 over 5 as a 1 over a and the tan inverse x over 5 plus c. So it is 1 over 10 tan inverse x over 5 plus c. So this is the answer. Now we are taking type 2. So type 2 is modified form. By substitution we convert this into a standard form. So it is we can say this is the method in which by substitution we use substitution method for standard form. It is 3x power 5 over 1 plus x to the power 12. So on taking 3, we have x to the power 5, 1 plus x to the power 6, but the denominator always should be in terms of 2 squares. So this is the 1 square, and x to the power 12 should be x to the power 6 square. So we will use substitution, that is x to the power 6 as t. So let x to the power 6 as t. Now this becomes on differentiation 6 x raised to the 5 dx equals to dt. So the value of x to the power 5 dx equals to 1 over 6 dt. Now we have the value of numerator right now, and on substitution x to the power 6 as t, we get new expression in terms of t, and the x to the power 5 dx is 1 over 6 dt. Now you can say it is 3 by 6, and this is 1 square plus t square dt. So it is half, and this is the formula format of tan inverse. So it is 1 over a tan inverse t over a plus c. As a result, we get tan inverse t, and the value of t is x to the power 6, means we have result, and this is the required answer. Now we are taking the next type third. So in this we have a format of question is just like a quadratic equation, ax square plus bx plus c, and we convert this denominator or a quadratic equation as a sum or difference of two squares. And for showing this result, summation or differences of two squares, we will use perfect square method. And this method says, step 1, the multiple of x square, or you can say coefficient of x square, should be 1 only. And step 2, this is the main step, and it is saying, according to this, we will convert the equation in terms of two squares. So we will add and subtract the half of coefficient of x. So we will square it, half of the coefficient of x, and we will add and subtract in the equation, and we will make the perfect square, and we get the special integral formats, means we have the three formulae, then we get as a result these three formulae, any one of these. So right now we apply this in any question, like we are taking a question, integration of dx over x square plus 6x plus 13. So right now we can see the multiple of x square is 1, so our first step is done. It is 1, so it is done. Right now we will apply the second step. According to this, we will check the multiple of x, that is 6, and the coefficient of x is 6, and we will half of it and square it and add and subtract, so we get 3. 3 square is 9, so the need of the step of this is add 9 and subtract 9. So we have this expression 6x plus 13. Right now we have two ways: either we add 9 and subtract 9, and one more thing, we can adjust 9 from this C, this part C, and if we collect 9 from this, we can use that. Otherwise we will go for add and subtract half of the coefficient of x square. So it is, right now we can see it is plus minus 3 square, or you can say plus minus 9. So we add 9 and we subtract 9. According to this, in next step this will be changed as x square plus 6x plus 9, and this is second part is 13 minus 9, and we get x plus 3 whole square, and this is 4. So right now we have x plus 3 whole square, and 4 means 2 square. Right now we have summation of two squares, so it follows the formula x square plus a square dx, that is 1 over a tan inverse x over a. So this becomes right now we change it into a standard format. So let x plus 3 as t. It means on differentiation we get dx equals to dt. Means when we put this in the final expression, we get x plus 3 as t, and this is 2 square, and this is dt. Right now this is a standard form. We use perfect square and a substitution method. We get this. According to this, a is 2, so the final answer will be 1 over 2 tan inverse t by 2 plus c, and when we substitute the value of t, we get 1 over 2 tan inverse x plus 3 by 2 plus c. This is the final answer. It is dx over 9x square minus 12x plus 8. So right now we can see clearly the coefficient of x square is 9. So according to perfect square rule, first we extract 9, and reaction becomes, this is 12 over 9 plus 8 over 9. Right now this is 1 over 9, and our first condition is fulfilled. Right now we go for second equation, second condition. It is 4 by 3 x plus 8 over 9, and that is the half of coefficient of x, and we square it and add and subtract. So according to this, the multiple of x is 4 by 3. So first we place half of 4 by 3 and then square it and add and subtract. So right now we cancel out this, so it is 2 by 3. It means we add and subtract 4 by 9. Right now we add x square minus 4 by 3x plus 4 by 9, and this is plus 8 over 9, and we subtract 4 over 9. So we do this plus 4 over 9 and minus 4 over 9. Now we have the equation is changed now. X minus 2 by 3 whole square, and the difference of this, when we take LCM as 9, this is 8 minus 4, so it is 4 by 9. You can say 2 by 3 square. Now we consider x minus 2 by 3 as t, and on differentiation we get dx equals to dt. Means this equation will change dt over t square plus 2 by 3 square, and this follows the formula of tan inverse. So result will be 1 over 9 1 over a tan inverse t over 2 by 3. It means when you cancel this 3, so it is 1 over 6 tan inverse, the value of t is x minus 2 by 3. So x minus 2 by 3 on taking LCM becomes 3x minus 2 by 3 divided by 2 by 3. So we can cancel 3 plus c. So answer is 1 over 6 tan inverse 3x minus 2 over 2 plus c. So you can write this answer as 1 over 6, this one, tan inverse 3x minus 2 over 2. So this is the answer of this integration plus c. Now next question, we can use the substitution method and perfect square method for making this question. So it is x over x to the power 4 minus x square plus 1 dx. Right now we can change this given expression in terms of x square minus x square plus 1. So we can see easily x square we can assume as x square as t, and we can collect the differentiation of x square as x. So it is 2x dx is dt. So it is x dx is half dt. We substitute these two. Right now x dx as half dt, and there is t square, x square as t, so it is t square minus t plus 1. Right now we have t square minus t plus 1. Now we apply the perfect square method. Right now the multiple of t square is 1, so our first equation is fulfilled, and the second condition we will half we will take the square of half of the multiplier of x, that is right now 1. So it is 1. So this is 1 by 2, square is 1 by 4. So we add 1 by 4 and subtract 1 by 4. So we apply this in this equation for making it as a perfect square. Right now this becomes t square minus t plus 1 by 4 and plus 1 minus 1 by 4 dt. And this first three components give the result t minus half whole square, and it is 1 minus 1 by 4 is 3 by 4, so you can say root 3 by 2 whole square dt. Right now we assume t minus half as u, so it is dt equals to du. Now the converted equation will be, that is u square plus root 3 by 2 whole square. This is the format of tan inverse equation. So we get 1 over root 3 by 2 tan inverse u over root 3 by 2. Now we place the value of u as t minus half and t is x square minus half. So finally we get 1 over root 3 tan inverse u as t minus half, and when we substitute x square, so it is x square minus half over root 3 by 2 plus c. So as a final result we can place it as 1 over root 3 tan inverse, on taking LCM this is 2x square minus 1 over root 3 plus c. This is the answer.